Okay, let me start then. So, I have this project for Border examples. Border is my game framework. For those that don't know, for people that might see this video later. And I was writing these examples because the way I work with this is that I make a couple examples that do certain stuff, basic stuff for now, and then I write the API to make that possible. So the first thing I had was a triangle, which I'm gonna show really quick. Hopefully it will work. So okay, here's a triangle, and hopefully it will not make my stream very slow showing this. And the way it works is that I have these archetypes of pipeline layouts. So here I have an empty one that just accepts a shader, so it's good for shader toy kind of stuff, and pretty much nothing else. It doesn't get buffers, doesn't get images, doesn't get uniforms, or it can't even do shader toys since it doesn't get uniforms. But if you just want to get a triangle, that's why you use empty. And then we have this buffer. It's wrongly highlighted here, but it's a string, and this is WGSL. And here what you have is a constant array of vertices and colors, and then we index into those using the vertex index. And what we're gonna do now, actually, let me zoom in. And here I'm starting this new one that is called sprites, but really it's just gonna be quads. And actually I'm gonna show what it's supposed to do later. If I get this video here, show it to you really quick. So it's a bunch of quads, and this video is really low quality, but you get the idea. Video compression really hates it. But you get a bunch of quads and explode them. And the idea here is to make a dynamic mesh. We update these vertices every frame, and then we animate them. So it's a pretty basic stuff to get kind of vertex buffer analog working. It's not a proper vertex buffer. We're not going to use that. In Border, I don't want to use vertex buffers because storage buffers can do everything. So we're just going to have those, and then you just make it index right in the shader. So let's see. Here I have this basis for this example. It's pretty bare bones, and it's also a lot of hacks here. I have to, since the API is really early stages yet, I had to pretty much reach into the internals of the library to be able to do this. So a lot of stuff here isn't exposed properly yet, but as I iterate on it, I will be exposing them, and then it will be a bit more comfy to use. But for now, it's more like you really have to know what you're doing. And since I am implementing things as I go, it's pretty much a lot of getting stuff that shouldn't be visible and then making it work. So, and currently in this example, what I have is just a stub for binding a buffer into the pipeline, and a shader that is incomplete, but it has a start buffer here, and it will have our vertex attributes. So our vertices will have a position and color. I'll uncomment this now since we're going to use it. And here's our struct, and then we're going to make an array of this and upload it to the GPU to use in the storage buffer, in the vertex shader. So let's see what we have here. I guess first thing is let's populate the buffer. I think I'm going to start with a triangle again. I'm going to implement the same thing I had in this example in this new one. So at first we just have a bag of vertices, and we're going to make it draw a triangle, and then later we're going to make the whole updating real-time thing to animate the quads. So okay, here I'm just gonna copy this, and then I'll make it back into scopes. is the language I'm using. So obviously this doesn't work here since it's WGSL, and I want to convert it to a natural thing that the language can use. Yeah, the teapot I can, not today I can't, but I suppose in the next example I can just bind async and then load a teapot to draw. That's not that hard to do after you get the buffer working. It's just a matter of imputing the right vertex data into the buffer. So okay, let's see. I have, yeah, okay. So this is going to be just a guide for what we have to do. And then we have an array. Array of vertex attributes, and then we're going to fill it. Okay, so here we have this, and I guess I should name it. Local, this one is vertices, this one should be vertex data. And then same thing here. Then it's back 4. Alright, so now we have the data we need, and it's just a matter of filling the array. Okay, position and color. Okay, so here we have our vertices. I'm gonna make a global vertices, same type, vertex attributes, and fill it in load. Okay, so now we have to figure out a way to upload this data to a vertex. And to be honest, I'm not sure if I have implemented this yet. Examine again. I should really put this the default font size. So what we have here, my group, And I don't think I have anything to create a buffer yet, so we're gonna have to figure that out. Yeah. We have a pipeline. Oh, we have a buffer module. Did I do anything? Bind group. Oh, this is a whole hacked up thing I did here. So I already had like the whole thing to create a storage buffer. I wonder if I did anything with this. I don't remember. It's been a while. So I was writing this to use it, and then I don't remember using it at all. Okay, so we have write. I must have copied this from somewhere. Maybe from the old, before the rewrite. So okay, let's see. I won't be creating bind groups here because we already created bind group explicitly here, and you can see it in action here. GPU bind group, yeah. So here we already have, it takes a buffer, a sampler, and a texture here. And I want to make a standalone buffer with our data. Okay, so it takes a size and a layout. Yeah, this is, we care about this, and we care about size and handle. And we have like big buffer. Okay. Buffer descriptor. Yeah, this all should work. Alright. Yeah, this is already ready to use, so I'm just gonna use it. And then we don't care about this. Care about this. Right is correct, although I don't want to use queue write buffer in the future since it's kind of inefficient. What you want to do is do persistent mapping. So we're gonna map on creation and then write our stuff and then map and then maybe do the mapping again every frame. But I think since that's a bit too complex to do right now, I'm just gonna use queue write buffer, which is a simplified version. And the reason you don't want to use this exactly is because since it's a queue method, let me zoom in again. Since it's a queue method, it gets executed during queue submission. So if you have multiple writes to the same buffer in a frame, you can't necessarily do them in the order you expected. So it's more so for doing the whole thing at once. So maybe you can like buffer writes on your own and then upload them all at once, but you can't override data. For example, you have to use separate slots and then make sure data doesn't touch each other. So okay, we're gonna use this. It doesn't need to know about bind group at all, so that's cool. Yeah, this should just work. Now, does this go anywhere? I guess for now, since there's no interface for using the GPU buffer struct here, we're going to have to extract this handle and pass the handle directly. So it's a bit hackish still. I'm going to do some integration between the types later, so you don't have to, because for now we're doing a lot of using WGPU directly here. I guess not necessarily in this one, but like there's a lot of passing handles around instead of, for example, here we're still passing the raw handle, and the idea with an API like this is that you don't have to know about the underlying API at all, although it is heavily modeled after WGPU. So it's not like you're shielded from it, but like I don't want you to have to deal with handles and whatnot and explicit resource management. So okay, we have this bind group here, GPU bind group. Yeah, you have dummies.buffer, and what's the type of this? Just see here, it's a common. GFX dummy resources. We have a buffer which is GPU resource binding, yes. Okay, so we create the buffer separately and then we put it in a GPU resource binding and then we use that to bind to the bind group. That seems straightforward enough. Okay, and where do I get that type, I guess? Let me see. I don't think it is in the types scope. Let me see. Init GPU pipeline, GPU shading module. Oh, GPU buffer it is. Okay, so I can just use it. Okay, here's our program global variables. This is all a total mess. It's alright because we're figuring things out as I go, but later I'm gonna clean it all up and make sure I don't have a lot of internal stuff going on in the example code. But for now, we just want it to work. So okay, global vertex buffer, which isn't really a vertex buffer, but we don't care. And the reason it's all options is because they're initialized on model.load, so I have to defer the constructor call. So they're like empty here, they're like none, and then when we load we put something in. Okay, vertex buffer, and for now we won't have an index buffer because I didn't write any code to support that, but it's alright because we can just repeat the vertices. And especially for the triangle, we don't care about that. But like when we get to a huge quad buffer like we did in the demo I showed you on YouTube earlier, then we definitely will want to use index buffers to minimize memory usage and bandwidth we use. Okay, vertex buffer is GPU buffer, and I don't remember what goes in the constructor. Let me see. And I really hope you can hear me, by the way, because let me see my messages. Yeah. Okay. What goes in the GPU buffer? Yeah, for now we just initialize it with the data. So yeah, we don't care about updates right now, so okay. That's gonna be for a later episode, I guess. So just gonna do what? Oh, okay. Oh, okay, you're right. We just pass size and a layout. We don't care about the layout anymore either. So it's just a size. And I reckon it's in bytes as well. Yeah, okay. So this is another thing that's pretty annoying. You have to calculate the size in bytes. I'm gonna get rid of this later as well, because we have types for a reason. I don't want to have to deal with this all the time. So, but for now, it is what it is. Let me just, we have here, let me grab this. And then the buff size, it's gonna be something like size of, size of buff vertices times count of, right? Oh, dot element type as well. So this is a convoluted way of saying size of vertex attributes times the number of elements in the array. But this makes it so I can change the type if I want it to be. Yes, the idiomatic way to do it. So we have the buffer size here, and then we should write it, I think. Yeah. And the data is supposed to be an array. Yeah. Yeah, it's all assumes you're using a dynamic array to feed this. But can we do this here? I think so, because in load the queue has been initialized already and it doesn't need to be done inside a frame, I think. I'm not sure. We're gonna try it out and see what happens. Actually, let me comment out the thing in the shader again. Since really what we want to do right now is just to test if this write succeeds. And then if we get this working, we can work towards actually binding it to the pipeline. But for now, it's just want to know if we can upload this data. And I'm not even going to test if it's the right data or not. We're going to leave that for when we try to draw the triangle. Okay, so I did just enough changes that this should still work. I didn't change anything that goes on in the rest of the drawing at all. Let's see. Yeah. Oh, typo. One too many R's. Vertex. Yeah. Should be a T. Oh. Position here is a vec2. Okay. Right. This should be vec2s. So yeah, every time I do a bit too much coding without running the program, I have to do these adjustments before running. What's next? This is vec2. Oh. What's wrong here? Let me try again. Oh, I didn't change it. Constructed themselves. And then I didn't return the vertex data. Okay. And here I need to unwrap it. Where? It's probably a better way to do this, but okay. So we're back to our black screen already. I think I didn't show this at the beginning, but this is what was going on beforehand anyway. So okay, time to actually put something there. Here we have dummies.buffer, and this is a GPU binding resource. I think we have this type as here as well. No, we don't. Oh, GPU resource binding. Okay. And what's the constructor for this? Oh, it's an enum, so it takes, so we gotta do like buffer and then pass in the handle, offset, and size. And here it's gonna be GPU resource binding.buffer, and it takes buffer exit size. Yeah, this gotta be done earlier. Let me move this. Okay, let me. Does this work? Should work. Yeah, you know what? Let me try this again. Just to be sure. Just a bit of changing things around. Does it still work? Yeah. Oh. Unwrapping it. Oh, right. Forgot to use the thing. Okay. So now, okay, here, okay. Pure resource binding, buffer is vbuffer.handle. It's a bit inconsistent whether I use underscore handle and handle. I'm gonna fix this later as well. But also, you're not supposed to use this. It's more like, okay, you're hacking into the graphics API and you want to use WGPU directly. It is an explicitly designed goal that you should be able to do this. And I'm using this right now because simply stuff is not built to use it correctly yet. So yeah, we gotta reach for those handles and hold it tightly. Buffer offset is 0. If I recall correctly, these offsets are right. Like if you want to bind into a section of a buffer, you use this. But right now we care about the whole buffer, so use 0 as offset. And size, right? Yeah. You already calculated the size, buffer size. And we gotta use this now. Okay, so here we gotta use vindex to index into the data, position and color. And this might just work. It didn't just work, okay. But this one is just I think I got a best view here. Let's move this later as well. Okay, here's a triangle. It's not colored. I don't remember. Oh, I guess I didn't use the color actually. Yeah, it's just once. So if I do, yeah, it should be after. Is it? Yeah, it's already filled out. Color, yeah, and it crashes. Oh, forgot the semicolon. That's a classic. I haven't used a semicolon in a trillion years. Okay, here we go. Triangle. That was way easier than expected, but since I had already left the code in a semi-working state, it wasn't so painful. All right. So we have a triangle. Now we gotta work towards quad. Quad is gonna be easy as well. Actually, I'm thinking I might just end it here while we're waiting. I need to do other stuff today, and sometime later this week I'm gonna continue and do maybe I'm gonna do a little bit of coding off screen, and then I'm gonna add the quads and make them fly randomly everywhere, and that's gonna be cool. Thanks for watching, and goodbye.